Here I'll be solving PS 6-3b. And do note that there have been some changes that have been updated to the problem, so make sure you have the most up-to-date version, which is on Moodle. Let's start with the exercises. Question 1, we have a ball being thrown with a velocity of 23 meters per second at an angle 15 degrees below the horizontal. So here's the velocity vector. And if this is the horizontal line, then that is 5 degrees. And assuming this is the positive x direction, and this is the positive y direction, then the vertical and horizontal components of the velocity we would write as 23 cosine 5 degrees, comma, negative 23 sine 5 degrees. Make sure you know what's positive and what's negative. The x component is clearly positive because this is cosine 5, but the y component is negative because this length is 23 sine 5, because it's the opposite side of that right triangle that's formed by the vector in the horizontal. And we also know that it should be a negative number, and so that's why we're writing 23 sine 5, negative 23 sine 5. It's going downwards in the negative y direction. Number 2, looks like the sled. If we represent the sled by this dot, then the sled is being pulled in this direction, perhaps. And this makes a 10-degree angle with the horizontal. And the tension in the rope is 30 newtons. So the force on the sled is 30 newtons from the rope. And so that means that the force is going to be 30 cosine 10, comma, 30 sine 10. Both positive in this case, assuming we've defined the same coordinates. Let's move on to the problems. Okay, first we have two forces that are being applied to a bolt in two different directions. So let's say the bolt is represented by that dot. And first we have 2,000 newtons in this direction. That's 30 degrees above the horizontal. And then we have another force being applied, which is 900 newtons. And that's going 45 degrees below the horizontal. And we have positive x in this direction and positive y in that direction. And so we should be able to represent the components of each force. If this is F1, then the components of that would be 2,000 cosine 30, comma, 2,000 sine 30. Okay, the reason why the x component is cosine is because this is an adjacent side, and this is an opposite side, which makes a sine on that side. And just multiply by the hypotenuse, which is 2,000. On the other hand, F2 is going to be 900 cosine 45, comma, negative 900 sine 45. And then if we evaluate it, we have to, because these are nice angles, we are going to get 1,000 root 3, comma, 1,000 for that. And here we're going to have 450 root 2, comma, negative 450 root 2. And so the combined force is just the vector sum, which will be 1,000 root 3 plus 450 root 2, comma, 1,000 minus 450 root 2 newtons is our answer. Next is a more complicated question. We have a tetherball. I don't know if you guys still know what the game is. We have a tetherball that is being pulled in 3 different directions. First, we have the force of gravity pulling it downwards. That's 1 pound that way. And then we have a force U that's pulling it horizontally. So this is a force U. Let's call this the force of gravity, vector Fg. And then in the up left direction, we have the force of the rope. Let's call this force T for tension. Okay, notice how they're all vectors. And so we're also given the fact that the tetherball is stationary. Actually, I don't know if it specifically says that, but that's what I meant by the question. So that tells us that the sum of the forces is going to be 0 as a vector sum. So Fg plus U plus T is going to equal 0. All right? So now let's figure out how to write this in terms of components so that we can actually set these forces to sum to 0. So let's clearly define what's positive and what's negative. So this is plus x, this is plus y. Okay, what is Fg? Fg is going to be 0, negative 1, because it's just pulling 1 pound downwards and there's no side-to-side component to the vector. On the other hand, U has only a horizontal component and it's pulling in the positive x direction. And so we would write this as U, 0. Here U is some kind of scalar. It's you can just think about it as the magnitude of the force. It's just the variable that we'll use to denote the magnitude of the force in the x direction. On the other hand, for T, this is going to form a 45-degree angle, right? So based on the diagram, we know that this is 45 degrees. Okay. And then, assuming that the magnitude of the vector T is also given by T, then that means that this force is going to have components like this. So it's pulling leftwards, so we know that it has to have a negative x component. And so we're going to have this be T, negative T sine 45. Why is it sine? That's because I've labeled the 45 here in this part. So that means that this component in this direction must be sine 45, right? It's the same as cosine, because sine and cosine 45 are the same, but that's why I wrote sine. And then the vertical component will be positive T cosine 45. Positive because it's in the plus y direction. Right, and we can just write this as negative root 2 over 2t and root 2 over 2t. Okay, so we have these broken up into components. And so now we can do this sum, because this tells us that all the x components sum to 0 and all the y components sum to 0. So u minus root 2 over 2t equals 0. Right, we're just adding up all the x components. And then adding up the y components, we have negative 1 plus root 2 over 2t equals 0. Okay, so this is not hard to solve. I would first probably start with the second equation. That would give us root 2 over 2t equals 1. And so t equals root 2. And then we would just plug that into the first equation. Isn't that right? If we plug that into the first equation, we'll get u minus root 2 over 2 times root 2 equals 0, which tells us that u equals 2 over 2, which is 1. Okay. So what's the question asking for? The tension in the rope is going to be √2 pounds, and the force U is also 1 pound. Let's keep going. Number 3. With respect to the air around it, a bird flies at a speed of 20 miles per hour to the east. So the bird is intending to fly, similar to the problem we got in class about the ant on the treadmill. A bird is flying at a speed of 20 miles per hour to the east, so V intended is 20 miles per hour to the east. Let's do our normal X and Y in that direction. But the wind pushes it such that with respect to the ground it ends up going northeast at a speed of 15 miles per hour. So it ends up going only this fast in that direction. So the V actual is somewhere there. This is 15, this is 20. And so we're looking for the vector that corresponds to the wind's velocity. Okay, that tells us that the wind is going to be pointing in this direction. The reason is because the actual velocity is equal to the sum of the intended velocity and the velocity of the wind. And these have to be added head to tail, right? Which is why I drew it in that configuration. Alright, so now what remains is for us to write these two vectors in terms of components, which will allow us to solve for the components of the velocity of the wind. So V actual, we can write that in components. This is going to be 15 √2/2, comma 15 √2/2, because this is a 45-degree angle. And then V intended is just 20, 0. And so that tells us that V wind is equal to V actual minus V intended, which is equal to 15 √2/2 minus 20, comma 15 √2/2. And we would write this in miles per hour. And that's all that the question asks us for. That concludes this video.